Okay, so this is the Wasp Wing Team MATLAB redo code that we made to calculate the coefficients of lift and drag. So at the beginning, we have an array for our angles of attack. We called it alpha, and then we have input for mean aerodynamic chord. We have our rho, which is going to be our atmospheric density. Then we have the pressure at sea level. And then this is just something that we used it before, and this is just a calculated surface area or a reference area that we used before um, to test it. This is also another chord length that we used. They're both input variables, as you can see there. Over here, we have the mean aerodynamic chord times all the coordinates of the airfoil. We use the coordinates later on to perform calculations. Um, so we multiply the coordinates of the airfoil to get, because the airfoil coordinates will give us the shape. And then you use the mean aerodynamic chord to find how long the chord is, how long the actual airfoil is. My apologies. Um, so we're gonna scroll down here, and we want all the x to be the first column and all the y to be the second column um, coordinates. So right here, if you can see, it cuts off at 0. So the top half is the upper wing points, and the bottom half is the lower wing coordinates. So these are just the corresponding x's, these are the corresponding y's. Alright, so for the upper part of the wing, we have the first 46, which is all the upper half of the wings. And then um, we perform calculations like the total velocity and the surface area and dynamic pressure, all in order to really just find the average normal force and the average axial force, which we found the equations that for lift and drag, we found the equations relied on a normal force and axial force. We repeated this step for the calculations in the while loop for all the points on the lower half of the wing. Then we calculate the average normal force and axial force. And since we didn't actually input an angle of attack, we left this as A equals 0 so that we can test whether or not this part works. And what you would get if your angle attack was actually like just 0 and you weren't flying. Um, Afterwards, we made it so that A wouldn't be equal to 0, and then we performed the while loops again so that it did include alpha or A right here. Um, then afterwards, we would calculate lift and drag, then the coefficients. Afterwards, we graphed the two figures, and so I'm going to run the code. What I input is just something we use to test to make sure that the code is running properly and that we can actually test it. So this is the figure for the coefficient of drag versus the coefficient versus the angle of attack, and then this is the coefficient of lift versus the angle of attack.